Hi, how's it going? Welcome to Code with Z. In today's video, we gotta generate all of the permutations of this array here. As you can see, this is LeetCode number 46, permutations, and I want you to know that I'll explain and visualize everything in the coming slides, literally everything, but for the sake of reading the question, let's see what the question is actually asking us for. So we're given an array called nums, and it's basically a bunch of distinct integers, and we gotta return all of the possible permutations. Let's check this example that we have here in our slides. To generate the permutations, we can be like, all right, we can have 1, 2, 3, and then we can have, I don't know, for example, 1, 3, 2, and then 2, 1, 3. You get the idea. So we basically have to go from this to this. Again, this is the same thing. 1, 2, 3, 1, 2, 3, and then 1, 3, 2, and then 2, 1, 3, 2, 3, 1, and so on and so forth. This is gonna be all of the permutations. Don't worry about anything because I literally visualize how we actually get to this answer. But when we usually talk about generating all of the answers and finding all of the possible answers and stuff, we usually have to use backtracking because backtracking basically gives us all of the possible answers. So let me visualize all of this. Let's ignore this for now, and I'll take this to here so we can actually have a little bit more space. We're gonna start with an empty array, and this is basically gonna represent our answers. In the beginning, obviously it's gonna be empty. So if we think about it, we're looking for permutations, right? So we can actually say, what will happen if we start adding 1 to our array? Or what would happen if we actually start from 2? Or even 3, right? So we're basically saying, let's explore all of the possibilities when we start with 1, we start with 2, and we start with 3. Then we're gonna be like, if we start with 1, that means we've used 1 here, and we have 2 other options. We can use 2 and 3. So we can either have 1 combined with 2, or 1 combined with 3. Well, let's do that. We're gonna be like, all right, 1 with 2, so 1 and 2, or 1 and 3. And then we're gonna be like, if we start from 2, that means we've already used 2, so we can either combine 2 with 1 or with 3. So we're gonna have 2 and 1, or 2 and 3, like so. And if we start from 3, we've used 3, so we can actually combine 3 with 1, and 2. So we're gonna say 3 and 1 or 3 and 2, like so. And then we're gonna be like, all right, let's check the possibility that we have here. If we actually have 1 and 2, that means we've used these 2 numbers. So the only number that we can add to it is gonna be 3. So we're gonna be like, all right, let's add 3. So we have 1, 2, and we can add 3. And then for this one, we can say, we've already used 1 and 3, right? So the only number remaining is gonna be 2. So let's add 2 to this one. And that's gonna give us 1, 3, 2. As you can see, 1, 3, and we added 2 to it, so that gave us 1, 3, 2. And then we're gonna come here and we're gonna be like, we've already used 2 and 1. What number is there that we've not used? Well, that's 3. So we're gonna be like, all right, we can have 2, 1, and 3, like so. And then we come here and we're gonna be like, we've used 2 and 3. What number is there that we've not used here? Well, that's gonna be 1. As you can see, 1 is not used. So we're gonna say 2, 3, and 1. And then same thing here, we've used 3 and 1. 2 is not used, so we're gonna add 2 here. And here, we've used 3 and 2, and 1 is not used, so we're gonna add 1 here. And if we check, these are gonna be our answers. These are literally the permutations that we saw in the previous slide. As you can see, 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. How do we know that we don't need to keep exploring further? Well, because first of all, we've used all of the numbers that we have here. And if you check, the permutations that we have are gonna be equal to the length of our original array. Like for example, if our array is 4, like if it has a length of 4, our permutations are gonna have also a length of 4. And for example, they won't have, I don't know, a length of 6, right? So the length of our array tells us the length of our permutations because they have to be equal. So these are gonna be our answers, and we're gonna add all of these to our result array, and we're gonna return this at the end. So we're gonna have a result array, and that's gonna be basically an array. And then we're gonna add these, and we're gonna return them at the end. Now let's code this in the simplest way possible. Alrighty, so the first thing that we're gonna do is to define a result variable, and this is gonna be equal to an empty array. Why an empty array? Well, if we check our examples here, when we return our answer, all of our answers are inside of an array. Each answer individually is an array by itself, just like we saw in the slides, but they're all inside of an array. As you can see here as well, our answers are an array by themselves, and they are inside of an array. And that's why here we initialize our result to an array. And then below this, we're gonna define our backtracking function like so, and this is gonna basically take a path. This path is the empty array that we started with. If you remember, we started with an empty array and then we kept on adding stuff to it. So for example, we kept adding 1, 2, 3 to it, and this was one of our answers, right? So this is going to be our path array. And when we actually find an answer, we're going to add this answer to our result array here. As you can see, we add 1, 2, 3, which is an array by itself, to our result array that we have here. So how do we know if we have an answer? Well, as we said in the slides, if the length of our answer, meaning length of our path, is equal to the length of our array, our original array, that means we have an answer. So we have to say result.push of our path. We're adding our path array to our result and we're going to return. That's going to be it. If the length of our path is equal to the length of our nums, that means we have an answer. Now, when we have a backtracking function and when we look for all of the possible answers, we have to call this backtracking function a bunch of times, right? Because we have to explore the possibility of what will happen if we start with 1, and then we're going to be like, no, what will happen if we start with 2? And then we're going to be like, no, let's see what will happen if we start with 3, right? So we actually have to explore all of these possible scenarios. So what will happen if we start with 1 and then we add 2 to it, just like we saw in the slides, right? So we have to call backtracking a bunch of times. So we're going to say, let's have a loop, because this is going to make it easy for us to call the function a bunch of times. We're going to say for let I being equal to 0, and we want to keep on looping as long as I is smaller than nums.length, meaning basically the length of our array, and we want to keep on incrementing I on each round, like so. And here we're going to be like, all right, we want to explore the possibility of what will happen if we start with 1, right? So we're going to say, all right, because we're currently looping through our array here, 1 is going to be nums of I, and then in the next round, 2 is going to be nums of I as well, because we're looping through this array. So we can basically say, what will happen if we add this number to our path? We want to explore this possibility. So what will happen if we start with 1 and add that to our path? We want to explore this possibility. So we're going to say, all right, let's call our backtracking function, and we're going to give it path, and we're going to be like, all right, you go check what will happen if we start with 1, right? We want to see what will happen, but in the next round of our loop, we want our path to be empty so we can see what will happen if we start with 2, right? So we have to actually pop that answer out of our path, because when we add it here, right, we're going to be like, all right, you go explore this scenario, right? But for me, because I have to worry about my next round in the loop, I got to make sure that my path is empty so I can see what will happen when we start with 2. And when we add 2 to our path, we're going to call our backtracking function, and we're going to be like, all right, you go explore this scenario and explore this possibility. But for me, I got to empty my path so I make sure I can explore the possibility of starting with 3 in the beginning, right? So this is why we add it, we explore it, and then we pop it. And this is going to be basically it. Then we have to call our backtracking function like so. And if you remember, in our tree, we started with an empty array and we kept on adding stuff to it, right? And that's going to be our path, because in the beginning, it's going to be just an empty array. And each time we find an answer, we add that answer to our result, and then we're going to return it. So let's return it. We're going to say return result. Like so. But if you remember, we actually kept track of all of the numbers that we used. We were like, we've used 1, so we can't use 1, but we can actually use 2 and 3. Or for example, if we did actually use 2, we would be like, all right, we can only use 1 and 3 because we've already used 2, right? So we have to have some sort of a logic that will check that for us. So we can basically say, if we had an array, for example, named used, I don't know, and we filled it with a bunch of false values, like so, false, 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 because the length of our array currently is 3, right? So we're going to have 3 falses here. And each time we use one of these numbers, we're going to say used of I should be equal to true. So we're going to be like, all right, we need to keep track if we've used this number. So we're going to say, hey, we're using this number, so used of I should be equal to true. So for example, if we start with 1 and we want to add 1 to our path, before that, we're going to say, hey, I'm using 1, so the position of 1 here should be equal to true. So this is basically what this line is doing. We start with false, and each time we use a number, we assign it to true. And then at the end, when we explore that scenario, when we pop it, we're going to say use of I should be equal to false. Because for example, again, when we start with 1, we're going to be like, all right, we used 1, add that to our path, go explore that scenario, but I have to worry about the next round in my loop. So I'm going to pop that out of the path because I want to explore what will happen if I just start with 2, right? Not with 1. And then because I want to explore what will happen if I start with 2, I want to be able to use 1 and 3 as well, right? So I have to assign 1 back to false. So these two lines are going to be basically telling us if we've used a number already or not. If we have used a number, we're going to say if use of I is equal to true, continue. It's basically like saying skip this round because we've already used this number and we don't want to add it again. Now, this is going to be our code, but the length of our nums might not be 3. As you can see, currently we're saying that the length of our array is going to be 3, and that's why we have 3 false statements inside of our use array. But if we check here, it's currently saying that the length of our array can be between 1 and 6. So to take care of this problem, we're going to say, all right, we know that we need to have an array filled with false values, right? So we're going to say, all right, let's have an array, and the length of this array can just be basically the length of our nums. And when we have this array, we just want to fill it with false statements. It's basically that simple. And this is going to give us that array that's filled with false values so we can keep track of each number that we use. Now, the last thing that we need to do is when we push this path inside of our result, we need to copy it. We can't just push it directly into our result. So we need to copy it and then push it inside of our result. So for copying, I'll just use this. This is basically how we copy an array usually in JavaScript. But all you need to know is that we're copying and then we're adding it to our result like so. And this is going to be all of our code, as you can see. Now let's run it and see if we're going to pass our tests. I hope I've not made any typos. Yep, as you can see, all 3 of the cases are passed. Awesome. Now let me submit it. Moment of truth. Drum roll, please. I'm just kidding. Let's see. Yep, as you can see, we're accepted. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.